Hello today. I am Chu Pan, a first-year PhD student in Industrial and Systems Engineering in The Ohio State University, and my advisor is Dr. Theodore Allen. Today I'm presenting on cybersecurity analytics in IoT dashboard based on PVC ThinkWorks. According to IBM data, manufacturing is the second most attacked industry. Yet the manufacturing sector is more vulnerable due to lack of investment in cybersecurity. There are multiple cybersecurity incidents in the real world that resulted in substantial cost to companies. So in this May, there is a data breach incident happened in Volkswagen that leaks some of their customers' contact, vehicle information, and some even had their driver's license numbers exposed. And 3 million people were impacted by this incident. In 2010, Stuxnet is a malware that caused substantial damage to the nuclear program of Iran. It ruined almost 1/5 of Iran's nuclear contributions. So nowadays, everything is going digitalization. Many cutting-edge technologies are being adopted by manufacturing industries to improve their production and performance. Then, how will this change the scope of cybersecurity? What are some tools that could possibly help with decision-making process? Let's figure out. This is the outline of my presentation, so I'll give an introduction and review the several concepts and show my proposed designs and discussions. First, let's begin with a little background on the digital transformation. So in the first industry revolution, manual production transitioned to machine production, and the second revolution took advantage of electrification and thus stepped into mass production. The third revolution related to mass customization and computers. And now Industry 4.0 is coming with enabling technologies like industrial Internet of Things, machine learning, artificial intelligence, cloud computing, virtual reality, and big data to help with automation and also automate the decision-making process. Let's dig a little further into IoT. So IoT is a framework that connects machines or a process that empowers them with computational capabilities. And the IoT is expected to create the following values. First, digitalization of data for monitoring. Second, reinforce the control in both business and manufacturing process such as connectivity with customers, operations management, security of the system, network, and intellectual property. Thirdly, optimize the production process and the performance, and also decision making. Lastly, advanced automation with higher interoperability. So this is an example of a typical IoT dashboard, which monitors the status of the injection molding machine. You can see the picture of the machine, and you can see the 3D simulation of real manufacturing in the tab of 3D simulation. And here we can see the control accuracy, the performance of the equipment, and all the operating parameters of this injection molding machine. Here in this plot, we can see the energy consumption, and we give recommendations on predictive maintenance and the reactive maintenance based on machine condition and control accuracy. And you can see in this one dashboard, all data in real time and everything in one screen. Is that easy? Then how about for cybersecurity? What matters to the security of the system? What are the inputs and outputs we want to look at? So on the left-hand side, the picture is just the diagram is just a simple model of an industrial control systems. We have PLCs that controls the sensors and equipment, and then we have the human machine interfaces above it. And all the data may be collected and shared and stored via cloud. So IoT and the cyber physical systems are combining physical components and digital networks, as we can see from the simplified model. So this actually changes how manufacturing companies automate processes and share information. So machine learning, big data, all of these enabling technologies of Industry 4.0 actually boosted significant improvements on data exchange, visibility, and industrial control. And all of this are moving forward the manufacturing industry to smart factories. However, a whole new range of security issues arise since multiple components are being integrated, including information technologies, operational technology, and intellectual property assets. So as we are connecting a whole bunch of machines, personal devices, and so on, every connected device represents a potential risk. Manufacturing such as industrial control systems have unique vulnerabilities that make them particularly susceptible to cyber attacks. For example, the human-machine interfaces used to be like mostly Windows-based, and the Windows is actually a system that most attackers are familiar with. And the Stuxnet, the malware that I mentioned at the beginning of this presentation, actually targets on SCADA systems and PLCs. A quick note is that SCADA is a computer-based system for gathering and analyzing real-time data to monitor and control equipment. Thirdly, manufacturing has fewer regulated compliance standards than other sectors. So Industry 4.0 connects previously isolated systems, which increases the attack surface and make it harder to defend these systems. For example, the programmable logic controllers, the PLCs, along with the human-machine interfaces, the HMIs, are designed for isolated environments previously. So adequate. So when we are to implement this kind of things, adequate cybersecurity measures may not be in place for them. As a result of the increase in connectivity between the operational technology, IT networks, this makes it likely for industrial control systems to be exposed to the internet. And the poor visibility across systems and isolated environments. Another cause of the cybersecurity events that I can think of at this moment is there's a kind of blind dependence on the IT security department. So in many companies, the primary responsibility of most IT department is to prevent external threats through firewall and account management. They're generally unfamiliar with the process reliability issues, equipment, and industrial protocols, and thus must work with the plant floor engineers, those we call local authority, to create an effective solution. And this might be a barrier of deliver a good solution or even have the problem solved. And lastly, production processes are continuous. This is kind of common sense. So the industrial control systems must be highly available, and any kind of unexpected outages for repair must be planned and scheduled. And timely response is critical because the cost of the attacks is substantial, and actually the components in the manufacturing control systems are usually distributed and isolated, so we need like more extra time to plan all of this repairs ahead. So we need timely response either to human reaction or physical sensors. And this is the design interface of the PDC ThinkWorks. You can see we can add data stream here. We can add widgets that's already provided by the website. So PDC ThinkWorks is an application development platform for the Internet of Things. There are other IoT platforms such as MindSphere from Siemens, and then Azure Power BI from Microsoft. So This is the cybersecurity analytics dashboard I designed, and we can see there are several blocks for different functions. We will come back to this dashboard and explain these blocks in detail later. And this is the inputs and outputs for the system. So we can, our system can monitor the activities in the network computer systems, and this include the incidents and abnormal activities. And we can see the result of vulnerability audit and the risk assessment and even the statistical analysis. And our goal actually is to increase the visibility of data that collected by our system and flag those vulnerabilities as soon as possible and as accurate as possible. And most importantly, ensure any weakness discovered can be carefully handled. This means that we track those weaknesses. Okay, and this block is showing the compliance history and the result. More details of each compliance and action can be added in the event analysis, and the engineers that are working on this incident can track the process and history of the security incident and take follow-up actions when needed. Say there's an unpatched vulnerability, and this requires actual work to work with the vendors. And there's another one that is patched, but the system recommends updating network policies after that. And if there's no practical mitigation strategy to address a certain vulnerability at this moment, an early notice would also provide extra time to resolve the issue. This is the analysis on asset inventory. So asset inventory is about gathering detailed hardware and software inventory information, and this will provide us with a base for targeting vulnerability scans and risk assessment. So here you can see in the circle is showing the core asset, and we have a ring that showing asset that are not that important. This kind of asset prioritization is important to security assessment and defense strategies. So we want, when there is an incident happen, we want our resources to be allocated based on purpose and sensitivity of each function. Actually, this holds true when there is no incident. So having this kind of graph will give us up-to-date information about the asset inventory. So here's the bubble map, gives a visualization of vulnerabilities in our system. So you can see there are a weak password, there are misuse trust relationship. So this actually help us identify and fix, say, outdated systems, vulnerabilities that are, say, unpatched and poorly secured files, and even like conduct a project to strengthen the password. And due to a recent report, breaches in the last 5 years have shown that attackers use multiple attack vectors to compromise an enterprise. So you actually need visibility for all sorts of security issues. This is a report of the incident. So the figure on the left is showing the number of incidents per tab. This will help us identify the weakness of the system, and we can take actions accordingly. Say there are many incidents happening these days about that start from a weak password. We can enforce the password strength. And the right-hand side graph is actually a kind of risk assessment. So from top to bottom, there are 3 goals: high, low, median. This kind of risk assessment can help us make better defense strategies based on emergency and the needs of the company. So there are some limitations of the study, and there are a research agenda that I propose at this moment. The statistics and the analytics I have at this dashboard may not be applicable for those larger companies with more complex systems. If they have more complex systems, they may also have like segmented systems for security concerns, and thus we may need an analytics on a single module or for a single department. And then interpreting the high dimensional data is actually a common problem to many researchers on Industry 4.0. Is because now we have these technologies and we get the massive data pool. How do we translate this kind of data into something that people understand and can help with decision making? And thirdly, more accurate prediction and analysis. There are multiple ways to modify our predictions. Say we can pull data from social media. We can utilize social media. The attackers might have bragged about their plan in Twitter, and if we catch these keywords before they actually take action on their attack plan, we can act right away and defend our system. Also, this dashboard can be tailored for different scenarios and use cases for different industries. I believe this kind of systems can also give recommendations not only in predictive manners, but also track the education project and give suggestions on education. Because as far as I know, many incidents also start from the inside employees, and this can be prevented at the beginning. Lastly, is simulation and modeling on individual industrial control systems modules, just like digital copy of the factory that I showed for the IoT dashboard. So the behavior of the system can be emulated with regards to how the industrial control system and its internal functions react and modify our defending strategies ahead. It can also be like if we take this strategy and change the parameters and input of this model, how can we avoid the POCs in say plan A being compromised at the end, or how much cost can we save by doing this, by doing that. So there are many research that can be done in this field, and these are the references that I use. Thank you for listening this presentation. If you have any question about this presentation or cybersecurity or IoT, feel free to contact me at fan.1039@osu.edu. Thank you.